related to the Viterbi, there is another algorithm called the forward algorithm. Okay, what is a forward algorithm? In the Viterbi, we are trying to find out the probability of the most likely path. Only one path I am interested in, best path, best sequence. Here in a forward algorithm, we are not interested in finding out the best probability. Again, this is inspired a little bit from soft alignment versus hard alignment. Let me just maybe okay, I'll try to finish it. So, what forward algorithm is trying to do is instead of, so the way to look at the forward algorithm is it's trying to find the total probability of explaining the whole data in, we are not only looking the best path, if there's an alternate path, we also see what is the probability of this. So, all possible paths we are accounting for and trying to find out what each one of them is trying to explain. Okay. So, what do I mean by that? So, remember this is basically the observation probability, right. So, in a Viterbi, what we are saying is, let me go here, we normally do a max. We want to see which is the path that is likely to, the path that is most likely to have reached here, right. Here I am not saying the most likely path, I am saying how probable is it that on day 2 I am in the sunny weather. That is all I am asking, not what is the best weather condition that I would have come here. So, I do not care whether I came through this condition or this condition or this condition. I am only interested in how probable is it that I have come to the sunny state on day 2. I do not care about what is the most likely way that I could have come to sunny weather. That is not what I am interested. That is only one path will come, the best path, the most likely, the best path. Here I am saying, what is the total probability? What is the total probability that I will be in the sunny state? I could come from this path and this path and this path. Total probability, what is it? Which will lead me to a sunny state. So, the difference is between Viterbi and the forward algorithm is just that the max, because I am not only looking for the best path, I am just looking for total probability. What is the probability that I will be here, right? So, that basically gives the summation, and so that is the only difference between the Viterbi algorithm and the forward algorithm. So, Viterbi only worries about what is the best way of explaining it. Forward algorithm basically looks at what is the total probability. Okay, what is most, how likely am I to be in the sunny state on day 2? That's all it's going to ask. That's all. Okay, not what is the best path that came and all that. How likely, what is the probability that I'll be in sunny? What is the probability that I'll be in cloudy on day 2, right? So, it basically is just trying to worry about in this state, how likely am I to be? That's all. Okay. So, it is a different kind of a thing. So, that is important for, we will see later the forward algorithm is good when you are training, because we are basically going to use the data in an efficient manner, but Viterbi is more useful when you are trying to do what is called the inferencing, when I want to find the best sequence of things, or when I am trying to find out the best path and so on, then the Viterbi is a very good idea. For training, we want to use the data much more efficiently. So, we want to use everything in an efficient manner, and I will explain to you in a simple terms why this kind of thing. I will take for example, GMM is a good way of trying to explain what I am trying to say, that instead of just doing a hard alignment versus a soft alignment, Viterbi is called as hard alignment, and forward algorithm is basically a soft alignment. Okay. So, we will come to that principle, and maybe I will use that example, and then we can stop, and I'll continue how HMMs are used. So, let me just go and explain what I mean by the soft versus hard alignment using a GMM example, and the same principle pretty much holds between the Viterbi and the forward algorithm. Okay. So, let me explain. I'll go back to the mixture of Gaussians for child versus men or something, or adult. In a park we had gone, if you recall, I had said that there are two distributions, right? So there is a child or children and there is a parent distribution, right? But we are only given measurements about height, right? So what we did was, let us say I had height measurements, 2 feet 8 inches, 2 feet 3 inches, 5 feet 7 inches, 5 feet 1 inch, 4 feet 11 inches, 3 feet 1 inch, 2 feet 1 inch, 2 feet 2 inches, like that I have measurements. Okay. But in a mixture of Gaussian, so this is something that we discussed some few classes back. You can go and look at mixture of Gaussians, right? So if you look at mixture of Gaussians, we had this idea of iterative algorithm, right? I take some random initial estimates of the density functions, then use this measurement to assign a class. The hidden variable is, this is the height, okay, or hidden or missing information is do not know whether it belongs to child or parent. That is the missing information. We do not know whether the measurement belongs to a child or a parent. So what we do is basically randomly initialize, and then we ask how probable is this measurement. So the first measurement, so H1, H2, H3, these are height measurements, H4, H5, H6, H7 and H8, right. So there are 8 measurements, and then we ask how probable is it from the child population and the parent population, and it so happens 2 feet is highly probable from the 0.95 and 0.05. Okay. 2 feet 3 inches is even more probable, like this, 0.99 and 0.01. Okay. 5 feet 7 inches is 0.79 and 0.21, because some teenagers also might be there in the playing the park, right? And 0.63 and 0.37 or something. Then this is a 0.58 and 0.42. This is 0.85 and 0.15, and this is 0.9, 2 feet, okay, 98 and 0.02, and this is 0.97 and 0.03, something like this we got. Okay. So now what will you do? You can do two ways. The hard alignment is, we will say child, parent, 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 child, 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 right? Why? How did I choose this? This is called hard alignment. 0.95 is bigger than parent 0.05. That's why I say this measurement is coming from child. So we assign child here. Similarly, 0.99 is higher than 0.01. So I say child. 0.79 is higher than 0.21. Therefore, it becomes parent, right? And similarly, 0.63 is greater than 0.37, so parent. 0.58 is greater than 0.42. Similarly, child, right? So we did beautifully this idea. Now it's very simple to get the mean, right? So what is the mean? So mean will become mean of children is what? So this is the H1, H2, H3, H4, H5, H6, H7, H8 is nothing but H1 plus H2 plus H6 plus H7 plus H8 by how many other? 3 plus 2, 5 measurements. Okay. Similarly, mu of parent is, what is the mu of parent? Is H3 plus H4 plus H5 by 3. This is how we are going to find, right? This is the analogy of Viterbi. We do a hard alignment, okay? We are finding only the best path, okay? Or we can have a soft alignment. So, here it is a weighted by the probabilities. So, here what do I do? I have to make it slightly smaller. How do I do it? So, here what we do, if I can, this is soft, I will write it here so that you can see the calculation. Mu c is going to be weighted average. So, it will be 0.95 times H1 plus 0.99 times H2 plus 0.21 times H3 plus 0.37 times H4 plus 0.42 times H5 plus 0.85 times H6 plus 0.98 times H7 plus 0.97 times H8 divided by 0.95 plus 0.99 plus 0.21 plus 0.37 plus 0.42 plus 0.85 plus 0.98 plus 0.97. This is soft, this is hard. So, if you can understand this, then you will know. So, I am using in the hard assignment, even if this becomes 0.51, if it is slightly larger, right, if it is 0.51, I will assign it to one of the two classes. I am going to give it to one or the other, the entire like data, this is like each one is like a data, precious data. I give it to whichever guy gets a majority, even simple majority, slightly higher, I give the entire data as if it is assigned to this. In the soft, I am saying, okay, 0.95 weight, because that is the weight that I am going to give to the height, and 0.05 is the parent weight. So, when I am calculating the parent, it will be 0.05 times H1 will come. Okay. So, I am weighting it by using how confident that data belongs to the particular class. So, I am highly confident, so I give more weight. Here I am very here I am less confident, therefore I am giving less weight. Okay. That is the basic idea we are trying to do in soft assignment. And so, now we are using all data points. So, you can see it is a sum. I am not looking for the max. So, I am trying to find the max of these two and assign to this, max of these two and assign, max of these two and assign. But here I am taking weighted sum of all of these things, and that is the difference between a Viterbi and a forward algorithm. So, forward algorithms are usually used when we train, so that we efficiently use the data. So, I will stop here. We will start how speech processing is used for HMMs are used in speech processing next class. Okay. Thank you.